Hello and welcome everyone. Today, I will share to you some information that will help you to your journey on the parallel universe. Just kidding, on the parallel and distributed computing. In a brief definition, a distributed computing is a model in which components of a super systems are shared among multiple computers. Even though the components are spread out across multiple computers, they run as one system or on a sink. Traditionally, computation is usually performed on one machine. Like when you input some information on a machine, the machine will process this information, then it throws some output. We always experience these basic things, like when we use our computers, our laptops, or mobile devices, or other computational devices. It is true that in our daily life, it is enough. But when we are talking about a larger projects or difficult computation, this thing is not enough on a single machine. Like when a social media company like Facebook processed their task, they did not process their task with a single machine. If not, then how did they process their task? The idea is simple. You take a large and complex task and actually chop it into bits, then distribute this task over a large number of computers so that each computers only need to process a small job. Remember, all the computers are working in unison, and as a result, you get back the result of your large computation in a far less time. Now that we know what is distributed computing, let's talk about the two useful things in distributed computing, the cloud and the Internet of Things. What is a cloud? So basically, in a normal cloud, there is a dense cluster of water molecules that appears as a single object from a distance. So, a computing cloud is a dense clusters of computers working together in such a way that to a normal observer, they all appear to be one giant computing resources. In short, that's the cloud. The stuff that appears to be running on your PC, your mobile phone, or any computing devices, but is actually running over the internet on an array of computers that are sharing resources with each other. So what is the Internet of Things? The internet isn't about computers anymore. Now, all kinds of everyday objects can connect to the internet, including cars, thermostats, sporting equipment, refrigerators, and even shoes. That is known as the Internet of Things. Now you may be wondering, why would shoes need to be connected to the internet? Well, shoes can collect data, like how many steps you take, which can be viewed from another internet devices, like smartphones, by using the cloud. So, all of these definitions are said, but how the cloud and Internet of Things works, or what is the architecture of the cloud and the Internet of Things? There are two distributed computing systems, HTC systems, or high throughput computing that falls to disparate nodes. That means each machine are independently working for a small job to produce a task. And HPC systems, or high performance computing, that falls to homogeneous nodes. That means each computers are performing the same task and are connected to each other. Both are used if you are dealing with complex and big tasks that will be processed in a short period or time. So let's start with the HPC side. The HPC systems is inside of a cluster of supercomputers or massively parallel processors or MPPs. The MPPs are working together simultaneously with super high-speed connections. So basically, MPPs is the centralized process control process. The cluster of or MPPs is inside of a computational and data grid, which handles the computation and the data processing. The computational data grids working together to supply the needs of a software, which are Web 2.0 service or any service-oriented architecture, Internet of Clouds or virtualization, and Internet of Things like RFID and sensors. HTC system side. Like I said earlier, the computers or the systems on it are processed independently. So HTC is not homogeneous nodes. Rather, it is disparate nodes. The independent computers or systems are connected as a peer-to-peer network that share files simultaneously. HTC use distributed control that is graphically sparse. So like HPC, the computational grid and data grids working together to supply the needs of a software, which I said earlier. So basically, an interconnection network in a parallel machine transfer information from any source node to any desired destination node. This task should be completed with as small latency as possible. Moreover, it should be inexpensive compared to the cost of the rest of the machine. So let's now back to our screen. As you can see, there is a diagram. This diagram shows the three interconnection networks for connecting servers, client hosts, and storage devices using the LAN, SAN, and NAS. So as you can see on the diagram, the nodes in a small cluster are mostly interconnected by an internet switch or a local area network. The local area network or LAN that shows in the diagram is typically used to connect client hosts to big server. A storage area network or SAN connects a server to network storage such as disks and arrays. Network attached on a storage or NAS connects client hosts directly to the disk arrays. So that's how interconnection works. Lastly, there is an information that I want to share to you. What is the difference between traditional computer and virtual machine? The gadgets that we are using today, like our computers, laptops, and mobile devices are traditional computers. Traditional computers runs with a host operating system specially tailored for its own hardware architecture. On the other hand, virtual machine is an emulation of a traditional computer. Meaning, virtual machines allow you to run a different operating system in a app window or e-software in your traditional computer, and that is what we call virtualization. Virtualization is the capability to run multiple instances of a computer system in the same hardware. There are 5 abstraction levels of virtualization, and now I will discuss it on my screen. Application level virtualization comes handy when you wish to virtualize only an application, because it does not virtualize an entire platform or environment. Library level or user level API. Virtualization with library interfaces is possible by controlling the communication link between application and the rest of the system through API hooks. So the next level is operating system level. Operating system level create isolated containers on a single physical server and the operating system instances to utilize the hardware and software hardware abstraction layer. The idea is to virtualize computer resources such as its processors, memory, and I/O devices. So instruction set level, MIPS binary code can run on an 86-base host machine with the help of ISA emulation. And that's all. I hope you learned something from this video. I am Jericho C. Villarasa, a computer science student. See you soon and happy learning. The reference is on the description.